complex number, the power of iota or I. So on today's lesson, we are going to go over the power of I. As you can see here, circle, let it be kind of unit circle. So the value of I, it depends. For example, if it is on the x-axis here, that goes to 1, and the y-axis, when it makes 90 degree, that is I, 180 degree minus 1, and 270 degree is minus I. So we'll see the value of I depending on its degree, or is depending on its exponent. So we'll focus on the exponent today. So let's split this into two. All right, let's see into two parts. If it is odd exponent and even exponent, what will happen? All right, even power, and if the power is odd. All right, so let's see. Let's start with I squared. Okay, I squared is obviously is minus 1. What will happen if it is I to the power of 6? Does it give the same thing? All right, let's see. So I to the power of 6 is the same as I squared. Let's express in terms of 2. This is our foundation, this is our basics. So that goes to 6 is 2 group of 3. All right, so then we have here I squared is the value of I squared is minus 1. Okay, minus 1 to the power of 3. So when the base is minus 1, if the power or the exponent is 3, obviously it's minus 1. Okay, so let's see another one, I to the power of 8. So this goes to I squared times 4. All right, I squared times 4. As you know, I squared is the same as minus 1. Minus 1 to the power of 4. Since the degree is 4 here, which means you are going to multiply minus 1 even times. So minus 1, minus 1, minus 1, minus 1. Those negative will be cancelled out. So you will have positive result. Right? You have positive 1. So as you can see here, you have 2. Even if the power or the exponent is even. So 1, you have a negative 1, you have positive 1. So let's come to the conclusion. What's the difference here? Okay, I want you to realize here the difference. Every 3 multiple, if the multiple is 3, that is odd, okay, you have a negative 1. And if the multiple is even, all right, so you have positive 1. So let's conclude this one. Okay, if I to the power of n, all right, I to the power of n, or let it be I to the power of I to the power of 2n. Okay, I to the power of n. So the value here will be either positive or negative 1. All right, so let's come to this one. I to the power of 2n will be the result will be 1 if and only if n is, all right, n is even. Okay, so the value of I to the power of 2n will be odd, will be negative 1 if and only if the value of n is odd. N is odd. Okay, so if I give you, for example, let me take a few examples here. For example, I 202, I to the power of 202. All right, so let's write this in terms of multiple of 2. This is the same as I 2 to the power of 101. All right, so 101 is odd, right? Therefore, we are going to have a positive. If it is odd, all right, if it is odd, we have a negative 1. The answer would be negative 1. Okay, let's see one example here. For example, 2026. All right, 2026. So let's express this as a multiple of 2. Okay, this is going to be I 2 group of 113, right? So 1013. So 1013 is odd. Since I have two odd, okay, let it be. Anyways, still it's the same thing, 1. What if it is I to the power of 200 or 2008? Okay, 2016. Okay, let it be. So I is equals to 2 group of 108. I mean 1008. Sorry, 1008. So 1008 is even. So if it is even, okay, if it is even, that goes to -1. I mean +1. Okay, so let's go to the second case where the power or the exponent of I is odd. All right, let's see some examples. Okay, let's start from simple. I to the power of 3. Okay, I to the power of 3 is the same as I squared, because I squared plus 1. Let's see the fact that I, or any number m to the power of n plus h, okay, or is the same as m to the power of n times m to the power of h. Okay, just keep this in mind. Let's apply here. Okay, this is the same as 2 to the power of I to the power of 2 times I to the power of 1. So as you know, I squared is the same as -1. That leads to -1, negative I. Okay, let's go to another odd. I to the power of, let it be 5. Okay, so this is the same as, this is a bit different. Okay, this is the same as I to the power of 4 plus 1, or 2 times 2 plus 1. Okay, let's split this into I to the power of 2 to the power of 2 times I. Okay, so in this case, the value of I squared is -1. When you squared it, that goes to positive. So that is going to be positive I. So whatever the case, if the degree is odd, the value will be either negative I or positive I. Therefore, let's draw conclusion here. So when you go down here, okay, I to the power of, let it be odd. Okay, let it be 2n plus 1. Okay, there you have 2. There you have 2 here times 1 times 2 times 3. So 2n plus 1. So in this case, the result will be either positive I or negative I. So when do you think it will be positive I? If and only if the value of n is odd. I mean even. N is even. Okay, so it would be negative I if and only if, as you can see here, the value of I is, I mean the value of n is odd. The value of n is odd. Okay, so let's see some example here. Okay, what's the value when I is the same as 21 here? That's definitely odd. So this is the same as I to the power of 2 group of 10 plus 1. All right, so here obviously it is even here, as you can see, it's 10. Therefore that lists as okay, we can even see anything here anyway. So that goes to even. All right, that goes to positive I. All right, what if it is like I to the power of, let's change the question to I to the power of 305. I don't know. All right, so let's see. So let's express this. 300 is the same as 2 group of 115, right? Or 152, shall we say 2? Okay. Okay, 152. All right, so plus 1. Okay, this is 304 plus 1. Okay, so this means, as you can see here, 152 is even. Okay, it is even. So the answer will definitely goes to, again, I. So let's see another. I to the power of 467. This is the same as, okay, I to the power of 2 group of something plus 1. So this means it should be 466. So 233. Good. So as you can see here, we have odd numbers. 233 is odd number. So that leads to negative I. So let me give you one more. Let's do one more. So let me give you one more example, or just try by yourself. I want you to pause the video and try. So which operation, or what should be the power of I, so that we will have here 1, I, minus 1, and minus I. So pause the video and try. Okay, what should be the power of I, so that we have kind of cyclic in nature type of questions. Okay, I hope you tried. I'm gonna give you only one, and then you just figure out the rest, which means you have multiples, or you have many or infinite number of possibilities to have this cyclic nature of power of I. So to start with, I'm gonna start from the simplest one. All right, so I to the power of, let it be 0. So this is obviously any number to the power of 0 except 0 is just 1. I to the power of 1 is just, obviously it is 1, I mean I. So next is I squared, that gives to minus 1. This is of course definition. And lastly, I cubed is going to be minus I. So this is just simple, or one example of power of I that gives you cyclic nature of I. So we have here, the first one is I to the power of 0. Now you have here I to the power of 1, here I squared, and then I to the power of 3. So you have multiple examples or infinite examples to solve this problem. I want you to try more than 10, more than 15. Okay.